In this video, I'm going to explain car following model and the important factors to increase the accuracy of car following simulation model. First, I'm going to explain different logics behind the car following model. So first one will be the most study model class called stimulus response model or GHR family of model. So this model assumes that follower's acceleration is proportional to speed of the follower, speed difference between follower and the leader, and the space headway. And this equation shows the sensitivity parameter in the microscopic models. This model will be further explained in the other video called car following problem solving video. And I will also explain the Green-Schultz relationship in that video too. And the second logic will be called the safety distance or collision avoidance model. So this model assumes that follower keeps safe distance between the follower and the leader. It's like when you take the driving test. And another example would be when follower keeps the safe distance of at least length of the car between every 10 miles per hour at which followers are traveling. And this safe distance is not set and it can be modified by manipulating the Newton's equation of motion. And the last one would be psychophysical models or action point models. So this model actually corrects the GHR model. The problem with the GHR model is that it assumes that follower reacts even when spacing between follower and leader is very large. And also it also assumes that follower would not react when the follower and the leader are moving at the same speed. So it corrects the GHR model by using threshold or action points where drivers change their behavior. In this model, drivers also react to changes in spacing and relative velocity when these thresholds are reached. So this graph illustrates how psychophysical model utilizes the thresholds to predict follower's reaction. First, the vertical axis here is the distance between follower and the leader, and the horizontal axis show relative velocity, which is calculated by subtracting leader speed from the follower speed. So 0 means that there's no relative speed or follower and the leader are moving at the same speed. And when the relative velocity is negative, follower is slower than leader. When it's positive, follower is faster than the leader. So as the distance between them increases, the follower is not likely to react to the leader's reaction. As the relative speed increases in either direction, the follower is likely to react to the leader's action. So this line here illustrates is an example of the follower's action. It first oscillates within the zone without reaction, which means that it's keeping appropriate distance and speed from the leader. However, the curved up portion means that once the leader accelerates, follower also accelerates. Now I'm going to explain how VISIM simulates car following based on psychophysical model. So this graph displays thresholds and regime in the relative speed and relative position space. Like I explained earlier, negative relative space means that follower is slower than the leader, and positive means that follower is accelerating faster than the leader. So first, the AX threshold represents desired distance between stationary vehicles, and ABX represents minimum following distance at low speed difference. SDX represents maximum following distance. SDV is when follower notices slow leading vehicle. CLDV is same as SDV but has smaller space between follower and the leader, and it's currently not used in VISIM. Lastly, OPDV is when follower notices that they're moving slower than the leader. So first, as the distance between follower and the leader increases and passes the upper limit of reaction, follower does not react to leader's action due to large space between them. Free driving is also the zone where driver is not influenced by leader's action due to large relative space. However, as the follower passes the SDV threshold and enters closing in regime, follower notices slow leading vehicle and decelerates in order to avoid collision. The following regime bounded by SDV, SDX, OPDV, and ABX is a zone where leader movement can affect follower reaction. This part between SDX, CLDV, ABX, SDV is still considered follower closing in but at much slower relative speed and distance. Lastly, this emergency regime is where relative distance is smaller than the minimum following distance at ABX. And in this zone, follower needs to decelerate in order to avoid colliding with the leader.